Hi dear students, this presentation is from 4th module of the subject EST 100 Engineering Mechanics. In this presentation we will discuss about impulse momentum equation. Now before moving into the equation we must have a basic idea about what is impulse force and what is momentum. Now we will first see what is impulsive force. When a large force acts over a short period of time, that force is called impulsive force. The examples of the impulsive force are when a batsman plays a shot for a six and when a bullet strikes the grass. These are all the examples of impulsive force. As we all know, when a batsman plays for a shot for six, what happens is he is exerting a very large force on the ball within a short interval of time. So it is an example for impulsive force. The same thing is happening in the second case also. Now impulsive force acting over a time interval of t1 to t2 is given by integral t1 to t2 f dt. So that product of large force f is multiplied by that time dt is integrated within that time limit, where f is the force, resultant force acting on the body. And momentum, I think all will be knowing. Momentum is nothing but the product of mass into velocity. If the mass is multiplied by the final velocity, then we will call it as final momentum, and if the mass is multiplied by initial velocity, then we will call it as initial momentum. And the change in final momentum minus initial that difference between final momentum and the initial momentum is known as the change in momentum. So by impulse momentum equation, what says is impulsive force will be equal to change in momentum. That is what is impulse momentum equation says. Now we want to derive the impulse momentum equation. So for deriving purpose, what we will consider, we will first consider the Newton's law of motion, that is equal to F is equal to ma, where F is the force acting on the body, m is the mass, and a is the acceleration. Now from the definition of the acceleration, we know that acceleration is nothing but rate of change of velocity. So a is equal to dv by dt. Therefore Newton's law becomes F is equal to m into dv by dt. Now I am taking the dt to the left side. So equation becomes F dt equal to m into dv. Now integrating on both sides, we will get, since F is constant, I am taking that to the outside of the integral. So F in integral t1 to t2 dt equal to m into, in the right side m is constant, mass is going to be constant. So integral becomes integral dv, and the limits are from velocity changes from initial velocity u to final velocity v. So integral limit is from u to v. Now integral dt is t and integral dv is v. Therefore equation becomes f into t, t1 to t2 equal to m into v, u to v. Now substituting the limits, f into t2 minus t1 equal to m into v minus u. Now we know t2 minus t1, this time interval is very small, therefore I am replacing it by a single term t. So f into t equal to m into v minus u. Now left side you can see it is a f, if f is very large and t is very small, f into t, the product is nothing but the impulsive force. So impulsive force equal to, right side I am taking that m into the bracket, that means m into v minus m into u. So mass into final velocity is nothing but final momentum, and mass into initial velocity u is nothing but initial momentum. So impulse force is actually equal to rate of change of momentum. So change in momentum, sorry, not rate of change, it is change in momentum. Impulse force is equal to change in momentum. Now this equation can be used to solve the problems in the case of mechanics. We will see a problem. Determine the tension in the strings and the velocity of 1500 Newton block as shown in figure 5 seconds after starting from case 1 rest and case 2 starting with a downward velocity of 3 meter per second. So in the problem what is given is, we can see two weights are there. Here 1500 Newton is fixed to a pulley, and here at the end of the rope we are having a 500 Newton. So of course this is the higher weight, so it will be moved, the 1500 Newton will be moving downward, and the same time the 500 Newton block will be moving upward. So in the first case what we want to find is the velocity of the 1500 Newton block after 5 seconds starting from rest. So in the first case it is starting from rest, so u is equal to 0. In the second case also we want to find the velocity after 5 seconds, but it is not starting from rest. Initially it is given that u is equal to 3 meter per second. So before moving to the solution side, we must have a basic idea about the movements of the weights connected here. In the earlier cases and all, we have seen all the problems with same motion, that is whatever distance 1500 is moving, the same distance 500 Newton also will be moving in the earlier cases, but here it is not like that. The distance moved by 1500 Newton is not same as that of the distance moved by the 500 Newton. The reason I will explain. See here that rope is connected at the roof, so it is fixed here, and also this pulley is also fixed to the roof, so this pulley also can't move, so it is fixed. But you can see this pulley can freely move along with the 1500 Newton. The reason is the rope is tied over this pulley, so actually pulley is hanging over the rope from the left side and right side. So if the rope is free, we are giving the free rope from this side, the pulley can move downward, or it can roll freely over this rope. But at the same time, what happens is, assume the case the 1500 Newton weight is moving downward, say x distance. Assume that it's moving x distance. So from both side of the rope, which is connected to this pulley, that is this side and from this side, if this pulley wants to move x distance downward, this side from this side and both from this side, the rope has to move x distance. So total distance of this rope is 2x. That much distance is to be provided from this side. So if pulley with 1500 Newton is moving downward and distance of x meter, then 500 Newton weight will be moving a distance of double that distance, that is 2x meter it is moving. So if it want to cover a distance of x meter, from here we want to provide a distance of 2x meter rope. So of course the 500 Newton weight will be moving the double the distance that this pulley is moving, or this weight is moving. So what happens is, actually the distance covered by the 1500 Newton will be half the distance of that of the 500 Newton block moving. So distance is here not same. So the same thing will be there with the velocity, since velocity is rate of change of distance, that is distance by time. If the distance moved is double, means the velocity will be double. But since the time is same, on the same time it is happening, so time is same here. So if the velocity distance moved is double, means velocity will be double. So the velocity of this 500 Newton block will be double that of this 1500 Newton block, and same thing will be there with the acceleration. And one more thing is, here you can see force is not same. You can see the dynamic equilibrium diagrams here, or free body diagram here. From this you can see that since both side rope is there for this pulley, so tension will be there on the both side of the top. Tension here and here will be there. Since it is the single rope passing over the pulley, so everywhere in the rope the tension will be same. So whatever tension is at the left side, same tension will be there at the right side, and also here also it will have the same tension. Everywhere the rope will have the same tension, since it is freely wounded over the pulley. Nowhere it is tied, only at this point it is tied, then it is freely moving over the pulley. So tension will be same. So in this case, here you can see it is 2 times tension is upward. So correspondingly in this rope tied to the pulley with the weight 1500 Newton, here we will have 2 times the tension, 2T will be there. So actually if you are drawing the block with 1500 Newton alone, then 1500 Newton weight will be acting downward and 2T times tension will be acting upward. But in the case of 500 Newton, the force is weight will be acting downward 500 Newton, but tension only, here one rope is there, so only one tension will be there, T. So you can see the difference here, 2T, 2 times the tensile force is acting upward, here only 1 T is acting upward. So these are all the basic differences. So now we will move on to the problem. When 1500 Newton block moves a distance s, in the same time 500 Newton block moves a distance of 2s. I have already explained. Whatever distance is moved by the 1500 Newton, the double the distance is to be moved by the 500 Newton block, and then only the motion will be same. Hence, if the velocity of 1500 Newton block is v, then velocity of the 500 Newton block will be double that velocity, that is 2v. So if the v is the final velocity of the 1500 Newton meter after 5 seconds, then the corresponding velocity of the 500 Newton will be 2 times that velocity, that is 2v. Let T be the tension in the cord connecting 500 Newton block, hence tension in the wire connecting 1500 Newton block will be 2 times that tension, that is 2T. Since the velocities of both blocks are different, only since we know that the velocities of both are different, so now we will move on to the problem. Initial case 1, u is equal to 0 and t is 5 seconds. Now writing impulsive momentum equation for 500 Newton block, we have, you can see here we are considering this block 500 Newton block. Here the force, net force acting is 500 Newton downward and T is acting upward. So 500 minus T or T minus 500, whatever may be, that is the net force. So here I am taking t minus 500. It is better to take the 500 Newton motion block will be moving upward, so upward force I am taking positive and downward force negative. So t is positive, 500 negative, t minus 500 is the net force, t minus 500 into t. So this is impulsive force, force into time, impulsive force. By impulsive moment equation, it says that it is mass into final velocity minus initial velocity. So instead of actually mass is weight by g, so 500 by g, this term is actually mass, into final velocity of the 500 Newton block is 2 times the velocity of the 1500 Newton block, that is 2v. So 2v minus u, here u is 0 since the block, both the block are starting from rest, so u is equal to 0. So t into 500 minus 5 equal to 2v minus, from this equation you will get t into value of, you will get an equation connecting t and v. T minus 500 equal to 200 by 9.8 into v. Now applying impulse moment equation to 1500 Newton block, we will get, you can see from here, the weight is moving downward, 1500 Newton weight is moving downward. So 1500 minus 2t will be the net force. So 1500 minus 2t into time interval is same, both is taking moving with the same time. So into t equal to mass is 1500 by 9.81. Initial final velocity of the 1500 Newton block is v. So v minus initial velocity is 0. So v minus 0, that's equal to 1500 minus 2t into 5. From that again we will get a relation connecting t, tension t and velocity v. Both are same, tension and velocity are same. So equate solving for these two, we will get v equal to 7.007 meter per second and t equal to 642.86 Newton. So now second case is initial velocity u is equal to 3 meter per second. So impulse momentum equation for 500 Newton body will be t into 500, t minus 500, same thing, net force is t minus 500 into time is 5, m is 500 by 9.8. Here 2v minus, instead of c, initial velocity is 0, initial velocity is 3. So I am substituting, from this you will get a relation between t and v, you will get a relation. Now going for the impulse moment equation for the 1500 Newton weight, you will get it as you will get second relation between t and v. Now solving for these two unknown, two equation, then you can solve for t and v. You will get v is equal to 9.15 meter per second and t is equal to 655.96 Newton.